Okay, so this is a video where we're going to dive deeply to figure out what the spark issue is with this engine. So from the previous video, you can see that essentially this was a seized engine. I did a whole bunch of upgrades and cleanups to get it as far as basically starting. So when this thing is behaving, it fires up right away and it runs not for very long, but it does run. Um, but the spark is an issue. So sometimes it's just no spark. Sometimes the spark comes back, sometimes the spark goes. And I noticed that when I just kind of wiggle the timing, when I physically wiggle it, the spark will come back. So it seems like it's most likely an issue to do with the distributor or a connection or something in the distributor ballpark. That's what the issue is. So what have I done so far? So let's take a quick look. So what I've done here is I've tested it. I've plugged a test light into the negative lead of the coil, right? So why did I do that? Because what you can view with this basic information is the status of the primary circuit, right? Of course, the spark plug tester is, testing the secondary circuit, right? That's the high voltage circuit. That's the one that gives you the spark. But the primary circuit, you can debug that separately to determine what the issue is, because there's a few components in the system, right? So you have the ignition control module, right? In this case, that's new, right? And then you have wiring towards the reluctor and the pickup coil inside the distributor, right? So if everything is working, right, the first part of the equation is the reluctor and the pickup coil will get a tiny spark, and that will then go to the ignition control module, and the ignition control module will then control the negative side of the coil and then produce a spark, and then of course the main will come in, and then you'll have the secondary spark to all this thing. So this distributor actually controls both the primary signal and then the secondary spark, right? So there's lots of components to the system. So you have to figure out exactly where it is, right? So when I hooked up the test lead, what did I see? Okay, so what I saw is when it was not behaving, essentially it wasn't producing any glowing, right? When it was working, it was producing glowing, it was producing sparks, and everything was okay. But even still, even with this thing, I think I noticed that every now and then there was no spark. So consistently, one of these plugs is not getting any spark. So that would seem to indicate that the issue is not with this, but most likely with somehow the pickup coil to the reluctor, right? So it is gapped correctly. I gapped it on the bench, so that's correct. But if you physically move it, it comes and goes. So either there's an issue, maybe with a shaft is wobbly, or maybe something to do with the pickup coil. But I measured the pickup coil. The pickup coil measures good. So something in this system is not working properly, right? So you need to debug it. Of course, start with a test light. But if you want to dive deeper, then you need a digital oscilloscope so you can monitor the signals coming from the negative lead. And if you can, you need an inductive pickup clamp. So then you can look at the signal coming from the pickup coil, and if you can put them on a 2-channel oscilloscope, you can look at them both together, and then you can get to the bottom of this as quickly as possible. So let's do that now and see what we see.
So let's take a look at the circuit diagram for the Mopar Electronic Ignition and see how that works. So this is a 5-pin module, but actually 4 pins, you can think of it, are really used. And very simply, you get a plus coming in from the run circuit, right? Goes through this ballast resistor and then goes to the coil, right? And also goes to the ignition. That's where the ignition module gets its power. But then the negative side of the coil goes to the module. So the module controls the grounding to the coil, right? And then you have these 2 pins here which go to the distributor pickup coil, right? So we are measuring, we're putting our oscilloscope lead on the negative side, right? So why are we doing that? So we're monitoring what the ignition module is doing to the negative side, and that will tell you all you need to know about what is happening on the primary side. Okay, so if you take a look at this diagram, this is what we're seeing. So this is what a healthy ignition system looks like, right? So start over here. You're getting what looks like ground. It's actually 1 volt, right? The ignition module is, let's just say, grounding the coil. So the primary circuit of the coil is getting 12 volts on one side and it's getting ground on the other. So during all this time, the Mopar ignition is actually powering this primary circuit, right? And it's drawing a lot of current. It's drawing like 5 amps. So as soon as you turn that key, this ignition module is draining 5 amps across this coil, right? It's huge. Now, it's not generating spark. It's just powering the field, right? No spark is generated when you're powering the field. Spark happens when you release this ground, and then essentially the field collapse, and that collapse causes a massive spike, right? So it starts with powering the field, right? Powering the field, and then the ground is released, and then a massive spike happens here, and then it kind of starts to die down till it hits the other side positive, right? So that's 12 volts, so it kind of hangs out there a little bit, and then it basically goes back down and goes to ground. So this is what the pickup, the magnetic pickup is doing. Every time these little tines pass, it induces a tiny little current inside this pickup coil, and that pickup coil goes to that module, and it takes that little tiny circuit, little tiny signal, and then converts it to a ground release. Right, it releases ground, and that released ground causes a massive spike in the primary circuit. Right, so this is our standard coil, ignition coil. So you have a primary circuit, right? That's these little 2 guys here, and then is wrapped around this core, and also the secondary coil is wrapped around there. And there's about 200 turns on the primary, but 22,000 turns on the secondary. That's how you step up the power onto that secondary circuit, so you can get a big fat blue spark coming from your spark plug wires, right? So when you have the ground circuit, you're powering up the primary field, right? So you're powering up this field. Because these are 2 wound together, the primary field creates an electromagnetic field, which then is induced into the secondary field. Okay, but it's stepped up by 1,000 times, right, or 100 times. So, and when the primary circuit collapses, you generate a spark, which is this one. So this is the spark on the primary circuit. It's about 200 volts, right? And then, of course, the secondary circuit will then also create another spark, which is 100 times more at 22,000 volts. Right, but by monitoring this negative lead of the coil, you can see how the electronic ignition is behaving, how it is behaving consistently, if you're the same across all 8 plugs, if your heights are the same, if your widths are the same, and then you can see what is happening on that circuit. The reason why I'm suggesting also to take a look at the secondary circuit is so then you can also see what this tiny little coil is doing, right? So there are actually 3 coils, right? There's this pickup coil, then there's a primary coil, and there's a secondary coil. So there's 3 components to this whole system.
Okay, so we have the oscilloscope hooked up. We got 2 channels showing. So the blue signal is coming from the ignition control module. The yellow signal is coming from the inductive pickup clamp. Unfortunately, the clamp is very noisy, but we do get a general idea of what is going on. So let's fire this thing up and we'll see what signals we're getting. So we're seeing almost no sparks coming from the ignition control module, and we are seeing that when there is a spark on the blue here, we do see that there's a strong spark from the clamp, right? So it does appear that the clamp is just simply not producing enough pulses for the control module to pick up. So this does seem to indicate that there's nothing wrong with the ignition control module. There's something wrong with the pickup. So here we have the new distributor on the bench, and before putting it on, I'm just going to take a look at the spacing here of the pickup and the coil. And it should be 0.008 thou, but it is pretty consistent. It might even be actually more than 0.008. Now, even that one looks like it's even larger, right? So let's take a look and see how I've had it set. So this is my coil. It seems to be okay, but I don't know, maybe I'm gonna try just kind of opening it up a little bit. Maybe it's too close, and I don't know, maybe it's too close. I'm just gonna give it just a little bit more and then see if that makes a difference. Maybe some of the tines are hitting. Let me try that. Okay, so with just a slight gap, let's see if we get an improved spark. No, we're getting nothing now. So it looks like that pickup coil is just simply struggling, and nothing is gonna make it happy. So let's just plug in the new distributor and see if that makes a difference. So these are the two distributors. Now this one is super cheap. I got this for $100 on Amazon, but unfortunately this is for an RB, which is a 440. This is different. This has got a shorter shaft. This is just a regular B, but this is like triple as much on Amazon. So, but I can just maybe hold it there and figure it out. Or what I could do is I could take the reluctor and the pickup from this one and then put it on my old one and also see what's happening. But let's first start by just seeing if we can just hold it there and get this thing sparking. Okay, so I'm just going to hold this in place. Let's see what type of spark we get, which is the blue signal, just to see if we get consistent spark. All right, here we go. It looks like it's a much better spark. Try it again. Well, there's much more spark here. Well, I was expecting much better spark. Why isn't it much better? You're not catching all this? See, now I'm not catching anything. All right, come on, man. We're still not catching everything. What's going on here? It's better, but we should be catching absolutely everything. Come on, man. See that? You're not catching anything there. Hold on. Okay, so I took apart the new distributor and just took the parts out and replaced this whole pickup coil mounting bracket with levers, etc., and new reluctor, which, by the way, is not machined properly from China, so it was really hard to get this thing on. Anyways, but it looks like the fit is good. It's nice and smooth. Let's plug this in and see if the spark gets any better. Okay, new pickup coil, new reluctor, Same old distributor. Nothing else has changed. Let's see if the spark gets any better. No change. No change. What the hell, man? Wow. Zero spark. Zero spark. Wow. Okay, I tightened the gap a little bit more. It was a little bit big, but I didn't think it would matter, but maybe it does. Now it is right as close as I can get it. This should spark off. All right, let's see what we got here. Wow, what a difference. My God. I didn't move it that much. My goodness. What a difference that makes. Okay, this thing should spark up now. Okay, here's the fuel. The fuel. No fuel. Come on, man. Where's the fuel? What happened to the fuel? I'm not getting anything. You know what? I may be out of fuel. Yeah, I don't smell any fuel. Oh. Yeah, no fuel. So close. Okay, here we are back. We've got full tank of gas this time. It's been a couple days, so we're gonna make sure that what we did last time was actually a fix, and it wasn't just a, kludge of a, bad wiring connection or whatever. So I'm expecting good spikes on the positive, on the primary, and I'm expecting the same fire on the secondary. So let's get our primer. We should have now. Woo! Yeah, we got fuel in here now. All right, let's go. Woo! And again. Okay. timing might not be 100%. Come on. Yeah, so the timing's a little off here. Come on, man. Okay, having set the timing, I think roughly about right, she starts up good.